Assalamu alaikum, everyone. This is Dr. Ghulam Mustafa Abro, and today the topic that I'm going to present in front of you is integrating AI-driven robust control algorithm with 3D hand gesture recognition to track an underactuated quadrotor unmanned aerial vehicle. And this work is jointly supported by Interdisciplinary Research Center for Aviation and Space Exploration, King Fahd University of Petroleum and Minerals, and undergraduate research exploration program. Sorry. Please note that this research work belongs to my student who performed this work under my supervision under U Explore program. So moving further, this presentation contains our following slides. We start from introduction, then we discuss briefly about literature review, from which we have derived our problem statement. We propose our methodology, then discuss some results and their outcomes. And then lastly, I would like to conclude the presentation, followed by a small acknowledgement and references as well. So, ladies and gentlemen, formally starting our presentation, we have witnessed that drones, especially the multi-rotor drones, they have been, evolving from time to time. You can see different multi-rotors drone. They are tri-rotor. You can see bi-rotor. You can see four rotors. You can see multi-rotors coming with. They are equipped with manipulators. They are equipped with cable-driven manipulators. They are equipped with cameras, so there are so many options. They have been evolving so now. The only issue that has been remained for so long is to stabilize it and control it under the external disturbances. So in this particular research, what we are doing, we are actually maximizing the effort of our classical control, which is PID, with the help of deep reinforcement learning. And the algorithm that we are proposing is Deep Deterministic Policy Gradient, which will actually identify the 3D hand gesture and then compute a reward function. That reward function will trigger our PID controls, actually the KP, KI, and KD gains, so that our drone can maneuver stabilizely. And above all, if we move further for our literature review, you can see there are the latest approaches. You can see they have so many limitations, like in some of the algorithms PID has been performing very well, but then suddenly in new scenarios it has been outperformed by some another algorithm. You can see that in some of the algorithms there is a limited robustness under certain conditions, but once conditions are changed, the robustness decreases. Then there are some promising results, but again, when it comes to uncertainties, then again the problem is there that further investigation is required. If we talk about some of the control algorithms, like the second last, you can see that performance may vary based on accuracy of disturbance estimation. So again, we need a disturbance observer as well. So keeping up all these research contributions, we come up with a problem statement that even these classical controls have been hybridized with reinforcement learning for navigation and control. Challenges remain due to the environmental factors and the field of a view of a camera as well. And this is why uh, our environmental conditions and cameras restricted field of view hamper gesture recognition, makes it impossible for our drone to control. So over here, what we are doing, we are mixing reinforcement learning with classical control algorithms so that the results are maximized. So ladies and gentlemen, this slide is related to methodology. You can see the block diagram over here, where different hand gestures are treated as a single input, and they travel through reinforcement learning module. We opt their skeletal output. That skeletal output we give it to inertial measurement unit, and then we compute our reward functions, which eventually trigger our proportional, integral, and derivative control for triggering and maneuvering our drones. Ladies and gentlemen, you can see over here the results and discussions about the results and discussions that you can see the graphs. The above six graphs are six different reward estimation for different directions, and the below one you can see that they are the reinforcement learning powered PID control, which initializes the states in the presence of 3D hand gestures. We move further. You can see this is my student. I'm really proud to introduce Mr. Ibrahim, who is my student, and he just graduated and joined Georgia Tech University for master's program. Really brilliant guy. He is actually training, giving a training to his model, and so that the model, the camera itself, identifies the 3D hand gestures. And above his head, you can see there are calibrated IMU based attitude control response that you can visualize. Now it's time to conclude the entire presentation. Recent advancements in reinforcement learning no doubt has changed the dynamics of or changed the I can say simply that it has evolved the drones in terms of stability control. But again, the environmental factors and the field of view or related to camera is kind of the constraints that are still there. So why not we just hybridize the RL algorithm with our classical PID control, so that the maximum perks can be maximized further, and we can witness the good UAV performance. This is a acknowledgement slide. I always say that I never walked alone. And first of all, I would like to thank Ibrahim Al Shaib. He, live it up to my expectations. And then we have Dr. Rozan from UITM and Dr. Fawad. They both were mentors together with me for Ibrahim's work. And no doubt, this research was incomplete without the support of Interdisciplinary Research Center for Aviation and Space Exploration, which is actually led by our director, Dr. Aman M. Abdullah. Without his support and without center's facility, we couldn't able to complete this work. So my all gratitude and sincere gratitude to all of them. These are the references, and yeah, that's it. Thank you for your attention and listening my presentation with patience. Now I'm open to answer the question and question open to the question and answer session. So it would be really helpful if any suggestions is there, so that we can extend this work a bit. What we are trying to implement the same algorithm now to medium scale drones and for large scaled multi rotor drones. Later on, maybe we can do the same thing for our fixed wing drones as well. Thank you so much, gentlemen.